Hello there, this is Randy. Today we're going to talk about 4 properties of rational exponents, and then we will apply those in specific problems. If you're wondering what are rational exponents, that just means exponents that can be written as fractions. Let's go. So right here, you can see the 4 different properties that we're going to talk about real quick before we try to apply them. So this first property right here basically says that if we have 1 over a variable with a negative exponent, right, you can see this negative a right here, then we can rewrite that expression as simply the denominator, but with a positive exponent, right? So if we say x to the power of a, this is like saying x to the power of a all over 1. Okay? Now this next property states that if we have a number to some power and then divided by that same number, notice x, those are the same number, divided by that same number to a different power, we can actually write that as the following expression. We just say that original number that we had right here and right here, and then we say that first exponent minus that second exponent. In this case, we're calling it a minus b. This third property is very similar to that second one. But this time, if we have some number and then that same number, and they're being multiplied, and they have some exponents, in this case, we're calling the first exponent a and the second exponent b, we can rewrite that as that original number to the power of the sum of those two exponents. So this a corresponds to this a, and this b corresponds to this b. Now this fourth property states that if we have some number to a power, and then that entire expression is raised to another power, in this case the powers are a and b, then we can actually write that expression as the original number to the power of the product of the two powers that were in the original expression. In this case, we're calling it a times b. Now let's see if we can pair each of these 4 properties with specific problems, and then eventually we're going to try to solve those problems. So over here, we have 4 expressions that we're going to try to rewrite in the form of x to the power of n. That's x to the power of n. Now, in just a moment, I would like for you to pause the video and draw an arrow from each of these properties to its corresponding expression over here. I'll do the first one. So this second property that we discussed corresponds to this problem right here, because this expression right here is in the form x to the a over x to the b. A corresponds to 5 over 4, and b corresponds to 1 over 4. So just like I have an arrow right here, I want you to pause the video and try to draw the rest of the arrows. Okay, hopefully you know where all your arrows go, and we're going to do it together now. This part wasn't that complicated. This first property goes with the first expression, and then this third property goes with the third expression, and this fourth property goes with the fourth expression. Now let's try to actually answer these questions. So now you can see each property here on the left next to its corresponding expression here on the right. So this first expression looks like this first property. So the property states that we can rewrite the denominator over here on the right, except this time with the exponent being positive. So the negative 5 over 6 corresponds to the negative a, and now this a right here corresponds to the positive 5 over 6. And we now have the form x to the power of n, because x corresponds to the x, and 5 over 6 corresponds to the n. So that first one was probably the easiest. Let's try the second one. So it looks like a this time corresponds to the exponent 5 over 4, and b corresponds to 1 over 4. And our rewriting of this expression is going to be in the form x to the a minus b, and eventually a minus b should correspond to n once we simplify. So there it is. 5 over 4 is a and 1 over 4 is b. So 5 over 4 minus 1 over 4. Thankfully, we already have common denominator, so we don't need to find a common denominator. And so this difference will be 5 minus 1 is 4. So 4 over 4, or 1. And there it is. So 5 minus 1 is 4, and we keep that same denominator. So 4 goes right here in that denominator. And when we simplify 4 over 4, we get just 1. So now we have x corresponds to x, and 1 corresponds to n. So we do have the form x to the n. So before we do this third example right here, I'm going to say that if you forgot how to find a common denominator between fractions, I would encourage you to Google how to find the common denominator and practice that a little bit before doing this full lesson, because that will help you a lot. It's a topic from like 4th or 5th grade, but at this time, many people probably have forgotten it. That said, we're not going to go super in depth about how to find the common denominator, but we will get to practice that in this third example. So in this case, we have a corresponding to 3 over 4 and b corresponding to 2. And we need to do a plus b. So let's rewrite this expression. So here we have a plus b, but 3 over 4 and 2 over 1 do not have a common denominator. But it's pretty obvious in this case that the common denominator will be 4. So how do we find the correct fraction to replace 2 over 1? Well, the way I think about it is 1 times what is 4? 4, right? 1 times 4 is 4. So we know the denominator will be 4. Now we just need to do the numerator also times 4, because we did 1 times 4 to get that denominator. So 2 times 4 is 8. This new fraction will be 8 over 4. So by multiplying 2 over 1 times 4, we get 8 over 4. And now we have common denominators of 4. So we can say 3 plus 8 will give us 11. And then we have 11 over 4. And that is the form we want. We have x corresponding to x and 11 over 4 corresponding to n. Now in this last example, we have a power to a power. So a corresponds to 2 and b corresponds to 3 over 7. And we're going to multiply those two exponents. And so now we can just multiply across. So we're going to say 2 times 3 over 1 times 7. And that will give us 6 over 7. Just like that. So just like in the previous examples, we now have x to the n. X corresponds to x, and 6 over 7 in this case corresponds to n. So once we can pair the property with the expression, our job is not that difficult. The hardest part for some students will probably be finding the common denominators, because it's been so long since we've had to do that. Either way, it's going to be good practice. And now that we have reviewed and practiced every property, we are finished with this video. See you next time.